Okay, so we've been asked to sketch the following function, f of x is equal to x squared minus 4. And the first thing that we should note is by just looking at the rule, the x squared minus 4, we can pick up there from that x squared that the variable x is to a power of 2, that we're looking at a parabola here. So the first thing that you need to look and try identify, because there are only about 5 different functions in grade 10, but the first thing you should recognize and perhaps even just write down or just make a mental note of is the fact that you are dealing here with a parabola. So I'm just going to write that there. We are dealing with what is referred to or known as a parabola. And since we're sketching, we need to sort of have our canvas as an artist would need. But the canvas in maths is the Cartesian plane, and quite simply what we need to plot is just a very basic set of axes, this one being the y and the horizontal one being the x. But now this y, we should know in grade 10 is the same thing as f of x, and we need to start thinking in those terms. So we just want to plot a very basic one. We haven't scaled it or anything yet, and then we move on to the next step. Okay, and then the next thing we're going to do is just create a very simple table, and I'm just going to refer to this now as f of x just to get into the habit. And we're just going to pick, not completely at random, but we're just going to pick a couple of, or sample of the domain. So just in terms of getting on both sides of the axes, I'm just going to start at -2 and do -1, 0, and then go onto the other side, the positive side of the x-axis. So I'm just going to have those 5 different values, and then we're going to substitute those into the rule, and the rule is this part of the function. So I'm going to substitute in those values into that rule and then determine what f of x is equal to. So if we take -2 and we put it into what I've highlighted in orange, we're going to have -2 squared, and a negative times a negative is a positive, so it's going to be 4 minus 4. So that will end up being 0. f of x will be 0 when x is -2. You can just do the same process. -1 squared is 1. 1 minus 4 gives us -3. 0 is going to give us -4. And 1 will have -3. And 2 squared minus 4 is 2 squared is 4. 4 minus 4 is 0. Okay, and you should have maybe just noticed a little bit of an interesting pattern there in terms of the numbers. And these this table's actually given us 5 different coordinates that we can then go and plot onto the axis. So I'll start just by scaling the x-axis, and that should be fairly straightforward because we picked those values. So we just need to have 1, 2, -1, -2. And then we just need to look at the f of x values to determine how far we need to go. And you can see I almost need to go a little bit further down in terms of below the x-axis, because it goes all the way to -4. So 1, 2, 3, 4, and then just write those values there. Okay, and now we just start plotting the value. So at -2, f of x is equal to 0. I'm also just going to change this just so we don't get too confused, but that's the point there, and we can even write in the coordinate -2, 0. Next one is -1, -3. That's over there. That's -1, -3. And when x is 0, we've got 0, -4. And then it just happens almost like you can see the symmetry happening. At 1, we've got -3. At 2, we've got 0 again. So there we've got 2 and 0. And just a very rough sketch, but hopefully you can sort of see the shape of this particular function, and that it's parabolic. It's got that smiley face. Okay, now with all these sketching of functions, there's certain critical pieces of information that you need to show in your sketches. So I'm just going to take you through them. I'm actually going to start by just listing what they are. So first very important thing that we need to show is the intercepts with the axes. So where it cuts through an axis, whether it's an x or y axis, you need to be able to show that. And here we have already done that with the coordinates that we've plotted. So that's one there, that's one there, and 2, 0. Those are 3 intercepts with axes. So that's the first thing that we need to do. The next one that we need to do or demonstrate is we need to show the it's the axis of symmetry or the line of symmetry. So axis of symmetry, and not all functions will be symmetric necessarily, but this particular one should be fairly obvious. You can see the smiley face just shows it very clearly, but the axis of symmetry is actually on the y-axis, but they usually want you to show the equation of that, and the equation on the y-axis is actually x equals to 0. Now that's something we should have done in Form 2. And then the last thing we need to show, if it exists in the function, are the turning points or turning point. And in the case of a parabola, there's only one turning point, and that's also a point that we've already indicated because it was actually where it cuts the y-axis, and that's at the point 0, -4. And there we've sketched a parabola. Alright, so we asked to sketch the following function: f of x is equal to x squared minus 4. And just a quick observation, this particular function, we look at the variable x there, it's to the power of 2. So that x squared, the fact that the variable is to the power of 2, means that we're dealing with a function known as a parabola. Now, to sketch this particular function, we're going to start by using the most basic intuitive approach, which is to create a table. And in this table, we're going to have 2 columns, one for the x and one for the f of x. And we'll start by sampling some values for x, and the only thing we should really bear in mind is that we should have both negative and positive x values, so that we're going on either side of the y-axis. So fairly standard, I'm going to start at -2 and then make sure that I go with numbers on the positive side of the y or the f of x axis. And then the next step, we actually just do some substitution. So for the first one, when x is -2, I'm going to substitute it into the rule x squared minus 4x. So I'll actually take the value for x, substitute it in there. So -2 squared is going to be positive 4. 4 minus 4 will give me 0. So when x is -2, the f of x, it will be 0. So the input of -2, the output that you get is 0. I'm going to do the same process. I won't write it all out, but for -1, I'm going to get 1 minus 4, which will give me -3. 0 squared minus 4 is going to give me -4. 1 minus 3 is going to give me -3, and then 2 squared is 4. 4 minus 4 is 0. And now that I've got these 5 ordered pairs or coordinates, we can then go and start creating the actual graph itself. So to start doing that, what we're going to do is just create an x-axis and an f of x axis. Start with the x-axis because we just defined those values ourselves. So that's the x-axis, and that's obviously the horizontal, and our vertical will be the f of x axis. And we just put in the different values that we've defined there. So it's 1, 2, 0 there, -1, -2. And now we need to look at the f of x values to determine our scale for the f of x axis. And you can see it, the largest value is 0, and the smallest one's -4. So I think it's probably easiest to go in increments of 2. So we'll say that's -2, -4. And now we can begin the process of plotting our various points. So we'll start with the first ordered pair in the table, which is x is negative 2 and f of x is equal to 0. So negative 2 f of x is 0, so that's actually going to be on the x-axis itself. Then we move on to the next one, which is negative 1. When x is negative 1, y is equal to negative 3, so I'm just going to approximate, but we're somewhere over there. Then when x is equal to 0, so over there, the y is negative 4. So we're actually on the f of x axis, or the y cut. And from there, we then move to the positive side of the x-axis. When it's x is 1, the f of x is negative 3. And here you should start noticing this sort of symmetric sort of relationship between these points, and there's a mirror line which we'll discuss just now. But let's just finish the last point is when x is 2, y is 0, so that's also cutting the x-axis. And then we can quickly go and do a fairly crude sketch of this, and just so that we can get an indication of the shape. And here you can quite clearly see this parabolic shape. In this case, it's a smiley face. It also can be a sad face, but you can just see the curve that is very commonly identifiable as a parabola. And then finally, we just need to look at a couple of characteristics of functions that are quite important, and I've just listed them below. The first one being the intercepts with the axes, and luckily with our table, we actually identified all the three intercepts with the axes. The first one being there, when it's the coordinate negative 2, 0. Then there's the one where it cuts the f of x axis, which is 0, negative 4, and then the other one, 2, x is 2, and the f of x is 0. The second one, we need to look for axes or lines of symmetry. So this one's also, because of the sort of Denzel-Washington symmetric effect of this parabola, it should be fairly obvious where this line of symmetry is, or mirror line. And it's in this case, it is actually the f of x axis, so it's coming straight down, and often they want you to define that in terms of an equation. So in this particular function, the axis of symmetry is going to be x equals to 0. And then finally, we want to look for turning points, or in grade 10, we're actually only going to have functions with one turning point. And in this case, this is when the function, or the y values, start changing. And this we've also actually identified, and the turning point is at the f of x, where it cuts the f of x, which is at the coordinate 0, negative 4. So we've actually identified the major characteristics of this function.